So say you're me and you're finally done with traveling and conferences for the season, finally moved into your new office, finally finished and submitted a paper involving four-dimensional symmetry groups and monkeys, and now finally you get to rest. You've got a whole free Saturday ahead of you. You're going to take a break from math, do anything but math. Yes, you're going to hang out with your friends and bake. So you go to your friend Gwen Fisher's house, who makes her living making mathematical beadwork like this and designing instructions and exploring the theory, but cookies aren't beadwork, so you're probably safe from math there. Then there's Ruth of Sweets by Ruth, who knows how to make a good sturdy shortbread, and even though she's well-versed in math, there should be no problems because baking, and only baking, is a focus of the afternoon. Also, Andrea Hawksley is going to join, and sure, she's a software developer who creates mathematical art in her spare time, but come on, we're just making cookies, what could go wrong? Wait. What's that two-dimensional ruler doing there? Is that a square root of 2 rhombus? No, I'm sure it's just because nom rhombus. I mean, even if you're trying to relax and avoid math, cookies still need to have some shape, right? As long as we have these extra little rhombus cutouts, might as well stick them together. But that's when disaster strikes. Our natural senses of symmetry, color patterns, infinite tilings on the Euclidean plane. We have to have color symmetry. No, Gwen, why, oh why do you torture us so? No living thing deserves such torment. Oh, there we go. Nice save, Andrea. Tension resolved, we extend our tiling just a little bit, enjoying how they look like cubes in perspective, finishing with a nice symmetric section. I got to pay Gwen back for the color pattern thing by focusing on this fingernail mark. I'm focusing on that fingernail mark right now. And after baking the cookie, we all got to torment Walter the Walter dog by eating our delicious shortbread. Ruining symmetry. Oh, yeah.
Okay. Good batter.
Mm-hmm.
What was the joke you had? Short
braid.
Short braid.
Short braid. Oh, yeah.
Right.
Let's make
so
a short
if we
braid.
Make braids, they're short braids. So
Short braid.
Short braid.
Short braid.
Short braid. Well, maybe we'll just do one little short braid as a test. I mean, anyone with a passing interest in mathematics and symmetry probably can't help liking braids. I've done stuff with them, and so has Andrea, and Gwen has some cool designs involving them on her beadwork table right now. And wait, Andrea happens to have an unusual 5-strand braid she made as a necklace in her bag. Well, we definitely need to learn from her how that works. Oh, and of course you can't talk about braids without talking about knots and links, and Gwen wrote a paper involving those and has made a bunch of cool ones, and look, sections of infinite polyhedra. Must resist. We're only going to make a nice simple linked cookie with obligatory discussion of the Brownian property, of course, which normal braids have, as well as the Baromean rings. Care if something's Brownian or not?
Most useful.
Well, now I'm seeing how it's useful.
I mean, right, because this says I always have the blue on top of the yellow, so I don't have to fiddle with that. And then I can just... I don't know that this is going to look good when I'm done, but I'm not going to let that stop me from doing. It'll still taste blue, yellow, and pink. They're the same kind of braid.
Yeah. But one of them got to be a ring. The other one's jealous.
No, this is a branch of the infinite ring. Walter, look.
Walter thinks it looks delicious. Why do you think
He's not going to appreciate the art.
He appreciates
so
that you made
good.
something that's delicious.
Brownian cookie. So the yellow is completely on top of the red is completely on top of the blue, and the blue is completely on top of the yellow.
Which completely just is very counterintuitive. And if we flipped it over, it would still be Brownian, and Walter would still want to eat it.
No, back to simple shapes, like hexagons.
I feel like they're much more foolproof than our rhombic dodecahedron or triacondahedron idea.
Like rhombuses, hexagons also tile the plane, though an aperiodic tiling would be much more fun. How about the classic kites and darts? We can make our own cookie cutters out of cardstock using the correct proportions and then tile them following the matching rules. So many kites. So many darts.
Kites. Where am I? I like to eat these kinds of cookies aperiodically.
After an aperiodic tiling, the simple hexagonal tiling would be so boring, so the only reasonable thing to do is glue together the cookies with chocolatish stuff in 3D to form a truncated octahedron. I mean, for any regular polyhedron that is made out of triangles, if you truncate it, those triangles turn into hexagons. And we made this octahedral jig that brings 4 hexagons together at the correct angles, but we're not sure if our 2 halves are going to go together.
You can rotate it to see if it fits better in one
Yeah.
position.
No, there's a theorem that doesn't quite apply here. It needs to be like differentiable, continuously differentiable.
It's rigid enough that you can pick it up. I wouldn't drop it. I wouldn't try and squeeze it.
You could play fetch with Walter, but you wouldn't bring it back.
since the truncated octahedron actually worked, Andrea starts work on a truncated icosahedron while I make a cardstock jig for holding together cookies at the correct angle for a rhombic dodecahedron while the edible glue hardens. Yes, no wonder we made a square root 2 rhombus, because square root 2 is a diagonal of the square, which is what you need for this octahedrally symmetric polyhedron. Though I suppose if we'd made golden rhombuses, we could have gone for a rhombic tricontahedron. But anyway, the rhombic dodecahedron is working. And then, yeah.
No problem. Don't drop it inside.
I know.
There's a reason. Oh.
Oh no. Beautiful, quick, before anything changes.
For some reason, it reminds me of stained glass.
Yeah.
It's the Play-Doh coloring.
I was just gonna say.
I have tried making polyhedra out of stained glass, and it's again the thing where it doesn't quite fit. You just fill in the,
solder.
This is gonna taste a lot better than the solder did.
It's also
Tasting
thinner than
solder?
pure chocolate. If you were to use regular chocolate, it'd be a lot thicker.
This is gonna work. I think that worked.
We're done!
Nope. Obviously, we need to make every shape possible, so we're never really gonna be done. Somehow, Andrea comes up with jigs that work for the truncated icosahedron, a familiar shape sometimes known as a soccer ball or buckyball, except this one is for eating and not for kicking, though it is made out of molecules. And meanwhile, Gwen is making an army of tiny tetrahedra because sometimes she makes a Pinsky tetrahedra out of beads or baseball bats. So of course she has no trouble bending cookies to her mathematical will.
Right in there, right on top. Just gonna fit right there on top.
Oh, that works very well.
That actually worked way better than I thought it was going to. Serpent's cookie.
Nice.
Dun 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 dun. Dun 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 dun. That is so beautiful. That's the most delicious soccer ball I've ever seen.
But in the end, we accidentally left Walter alone in the room for 1 minute, and he ate them all and does not regret it one bit.